Hello guys, again we have got another numerical problem to be solved by the simultaneous differential equation. That is, there is two equation. So it is called a simultaneous, means one after another. There is two equation. First we have to convert it into symbolic form with the help of d. Then wherever there is d by dt, we are going to replace it by capital D. Then the above equation, this and this, going to be appear like this, means dx in the place of d by dt, it becomes capital D. So it becomes dx plus 2x minus 3 equal to 5t, which was there 5t. And then we got x value, we'll bring it together and we will take x common so that we can get our d plus 2 bracket x. In the same way, we're going to change this in our symbolic form. It becomes gy minus 3x plus 2y. Then here y and y term, we'll bring it together so that it can be this form. So this becomes equation 1, equation 2, and we have to cancel one of the term. Then let's cancel here the part of x. Then we can see here in equation 1 x is multiplied with d plus 2, but in equation 2 x is multiplied with minus 3. Means we have to make cross multiplication like this, 3 with this term and d plus 2 with this term. So operating d plus 2 on equation 2, this is equation 2. So we're going to operate our d plus 2 on equation 2. So finally we're going to get our required this value. This become our equation 3, and again we have to multiply 3 to equation 1. This is our this equation, so we'll multiply 3 on that, so we're going to get our equation 4. Now it can be solved. Equation 3 and 4 on solving, we can get that x term is cancelled and the remaining term is copied as usual. After solving, finally we got our required this form, and here is d. So later on we'll do derivative of this, and from here we can follow our usual process. Means first we have to calculate our auxiliary equation to get the value of d. So auxiliary equation equal to the coefficient of y equated to 0, which is minus 9 plus d plus 2 whole square equal to 0. So on solving, we came up to this form. On solving and solving, we should get our value of d. So we solved up to here. Then we got the value of our d in the form of 1 and minus 5, which are real and different. So we can write our CF equal to C1 e to the power, and the power constant, the variable according to the right hand side, which was d. So it becomes our required CF. Return the value of m1 and m2. Then after we're going to find our pi equal right hand side divided by function of d. Means what is the function of d? This is here without y, means we should remove the y. Then we got right hand side divided by function of d, this much. And what was our right hand side? And right hand side is this. On solving our right hand side, we can get up to here. Means wherever there is d multiplied with the other, then we have to do derivative of that term. Means we did here derivative of e to the power 20. So we got our value up to here. Hence final pi equal to right hand side, this is divided by function of d, which was solved up to here, function of d. So we can separate the numerator in two terms. Means it becomes, for the 15t it become 1, for the 8 e to the power 2t it become another expression. Now this is polynomial like as algebraic form. So we're going to solve with the help of polynomial assumption. That is, we'll apply that binomial way. We know how to solve, and after solving we got the term up to here pi1. Means how we did it by taking the common of lowest degree of d, which was d to the power 0. Here we took common of minus 5, so we got this value. Here power 1, then we will take it to the top, then it is going to minus 1, and we apply our binomial formula. So we got pi1 equal to this much. Similarly, we're going to solve our pi2 according to the exponential. So pi2, we solve it with the help of exponential, where d is replaced with a, that is 2, which is the coefficient of t in the power of e. So wherever we see D we replace there 2 and we got our pi2 up to this much. So pi equal to pi1 plus pi2 and this is our required pi. We know complete solution equal to cf plus pi and we return the value of cf and pi. But we see here we have given y because y was multiplied to the symbolic form of the auxiliary equation. This was our auxiliary equation, that is where y was multiplied. So the complete solution will be equal to the value of y. Then we got the value of y. So from any of the equation we should get the value of x. Let from equation 2 we get the value of x in this way, 3x equal to this, and we return the value of y. We open the bracket, means we multiply this term and this term, and wherever there was d, we did derivative one time because d has got power 1, and on doing so we got our value up to this much, and here was 3x, so 3 was sent there and it was got in divided term, so x is equal to 1 by 3, and our required expression is this.